Hey everyone, get ready for something truly extraordinary. The James Webb Space Telescope has just sent back jaw-dropping, terrifying images that we've in EVER seen before. This latest discovery is making waves in the world of astronomy, and today we're diving deep into the science behind these mysterious new images. What exactly did it capture, and why is everyone talking about it? Stick around as we unravel this mind-blowing cosmic revelation. Let's get started. For 2 years now, the James Webb Space Telescope has been delivering breathtaking images from the depths of space. As the most powerful telescope ever built, it has been revealing the oldest and most hidden secrets of the cosmos. But beyond the groundbreaking discoveries, it has also presented astronomers with some puzzling mysteries. For instance, how can there be galaxies out there that, according to our current understanding, shouldn't even exist? And why doesn't the value of the Hubble constant, measured by Webb, to track the universe's expansion align with the models we've been relying on? These are the burning questions experts are urgently trying to answer. Thankfully, the James Webb Space Telescope is not only a tool for unraveling the universe's most perplexing mysteries, but also for showcasing its overwhelming and, at times, almost terrifying beauty. The images it sends back remind us just how small we are in the grand scheme of things. We humans often think of ourselves as the pinnacle of creation. Whether or not we choose to embrace that lofty title is up to each of us. But when it comes to the universe's most awe-inspiring creations, the cosmos still holds the crown. It's clear who deserves the honor here. But let's not get confused. The James Webb Space Telescope hasn't uncovered some mysterious force behind the creation of the cosmos. What it has done, alongside Hubble, is give us an unprecedented combined view of one of the most iconic sites in space exploration, the Pillars of Creation. Located about 7,000 light-years away in the Eagle Nebula, these glowing pillars represent a stellar nursery where new stars are born. First captured by the Hubble Space Telescope, these towering clouds of gas and dust show us where stellar life begins. In these dense, cool regions, gas clumps together under the force of gravity, forming a protostar. This early star draws in matter from its surroundings, and once it gathers enough mass, it ignites hydrogen fusion in its core, becoming a fully fledged star. But stars often form in clusters, like those found in the Pillars of Creation. While Hubble's 1995 image captured this stunning structure in visible light, the James Webb Telescope took it a step further, peering into the pillars with infrared technology. The combination of these images has given us an entirely new understanding of these finger-like formations, revealing even more about the intricate process of star formation. These towering structures are larger than our entire solar system. Hidden within the dusty cosmic cocoons of the Pillars of Creation are countless newborn protostars and stars. The intense radiation and stellar winds from these stars have carved out gaping holes in the surrounding dust clouds, giving the pillars their unmistakable, awe-inspiring appearance. It's no wonder that in 2022, the Pillars of Creation were one of the first targets for the James Webb Space Telescope. Now, NASA has taken it a step further by combining images from both the Hubble and Webb telescopes, revealing even more breathtaking details. While the infrared images highlight the hidden protostars and cooler gas components, the visible light shows us the scorching hot, glowing gases of this cosmic star factory. But the experience doesn't end with a photo. There's also a stunning video. If you watch the clip, you'll be treated to a mesmerizing journey through the three-dimensional Pillars of Creation, with the view shifting between visible and infrared light. This dynamic presentation perfectly illustrates why exploring the same structure with different telescopes is so crucial to understanding the full picture. Webb recently captured a stunning family photo in the Serpent Nebula, located 1,300 light-years away. This region is yet another stellar nursery, specifically known as a reflection nebula. Unlike emission nebulae, reflection nebulae don't produce their own light. Instead, they are illuminated by the nearby stars within and around them. In the past, these nebulae presented insurmountable optical challenges for telescopes. However, Webb's near-infrared camera, NIRCom, has the unique ability to penetrate the thick layers of dust and gas, revealing what has long been hidden from our view. The images burst with vibrant shades of orange, red, and blue, showcasing the intense sparkle of countless young stars. Many of these dazzling celestial bodies are only about 100,000 years old, still in their infancy by astronomical standards, but destined to eventually have masses comparable to our Sun. One particularly striking feature in this stellar family portrait is the flame-like structures in the top left of the image, which resemble colossal shreds. These fascinating formations are traces of gas and radiation outflows from young stars, which appeared as mere blurred spots in earlier visible light images. This new perspective not only highlights the beauty of the Serpent Nebula, but also sheds light on the dynamic processes occurring within it. NASA likens these protostellar outflows to snow falling from the sky during a heavy storm, beautiful yet chaotic. This groundbreaking image is the first to reveal that all these outflows are pointing in the same direction. To us, they might just appear as structures moving from the top left to the bottom right of the image, but for researchers, this is significant evidence. It supports the theory that young stars tend to rotate in the same direction when their gaseous birth envelopes collapse. Now, what's the story behind the black bars in the bottom left and top right corners of the image? Did NASA use a sensor pen to hide a couple of UFOs? Unfortunately, it's not quite that thrilling. Those black rectangles simply indicate areas of missing data. Speaking of exciting discoveries, the first photo of the Super Jupiter, an exoplanet located 6,911 light-years away, is among the impressive finds made in the quest for new worlds. The number of known planetary systems orbiting stars beyond our Sun is growing almost daily, with researchers continually adding unusual celestial bodies to the star maps. One of these fascinating additions includes the gas giant, which offers a glimpse into the diverse range of planets out there in the cosmos. Meet HD 189733b, a fascinating exoplanet located just 63 light-years away. According to the latest findings, it smells like rotten eggs. While this might sound strange or even amusing, it actually marks the first evidence of hydrogen sulfide detected on an exoplanet. But that's not all. Experts have been busy sniffing out more intriguing discoveries in our cosmic neighborhood. We now know of several nearby exoplanets, some of which are Earth-sized and potentially capable of supporting life. One in particular, K218b, has been making headlines for months. This celestial body is suspected to be a full-blown ocean world, and scientists believe it may even host life. Thanks to Webb's near-infrared spectrometer, NIRSpec, we have captured potential biosignatures on K218b, including the spectral signatures of methane, carbon dioxide, and dimethyl sulfide, DMS. DMS is particularly interesting because it's produced on Earth by marine plankton and during the decomposition of organic matter. This molecule is a key contributor to atmospheric sulfur and is responsible for that distinctive marine smell. In fact, the signature we found wasn't immediately clear in the Webb data. It only emerged after the datasets were analyzed using a unique method. So, until we fully unravel the background of this exciting discovery, we'll need a bit more patience. On the other hand, a recent snapshot taken by Webb has offered a refreshing perspective. Despite the many exoplanets we've discovered, images of these alien worlds remain scarce. Most of what we've seen so far mainly features young, hot gas giants, which appear as bright spots in infrared light. However, there's a cooler story to tell. Just a few weeks ago, Elizabeth Matthews and her team from the Max Planck Institute for Astronomy in Heidelberg achieved a remarkable milestone. They successfully captured a cold, older exoplanet directly. The foundation for this groundbreaking image was laid by studying the triple star system Epsilon Indi, which is only 12 light-years away from us. This cosmic trio consists of two brown dwarfs and the orange dwarf star Epsilon Indi. Previous spectral analyses had already hinted at the existence of a large planetary companion. With this new direct observation, we're getting closer to understanding these distant worlds and their unique characteristics. Webb's mid-infrared spectrograph later confirmed that the Epsilon Indi system indeed hosts an exoplanet, but in a completely different location than previous studies had suggested. The reason for this discrepancy? Earlier analyses significantly underestimated the mass and orbit of this giant gas planet. What we're looking at here is a celestial body that can confidently be described as a super-Jupiter. For context, Jupiter, the largest planet in our solar system, has a diameter of about 140,000 kilometers and a mass 318 times that of Earth. In contrast, the bright point of light detected in the Epsilon Indi images is estimated to have a mass around 6 times that of our Jupiter. This massive exoplanet, dubbed Epsilon Indi b, orbits its host star, Epsilon Indi AE, in a relatively eccentric orbit. Its farthest distance from the star is approximately the same as the distance between our Sun and Neptune. As a result of this unusual orbit, Epsilon Indi b takes a staggering 200 years to complete a single revolution around its star. Interestingly, it was this eccentric orbit that explained the surprising deviations noted in earlier observations, as they had inadvertently detected the planet at a different position than anticipated. This new understanding opens up exciting avenues for exploring the dynamics of exoplanetary systems. At its closest point to the star in its orbit, Epsilon Indi b was mistakenly thought to be in a circular orbit. However, the latest analysis not only corrected this orbit, but also revealed some fascinating characteristics of this exoplanet. For starters, its average temperature hovers around 0°C, and at about 3.5 billion years old, this gas giant is no longer a planetary youngster. Of the roughly 25 exoplanets that have been directly imaged so far, most are less than 500 million years old, with the majority clocking in at under 100 million years. Against this backdrop, Epsilon Indi b stands out as both the coldest and the oldest exoplanet ever directly imaged. The images captured are not only stunning for scientists to behold, they also offer immense potential for new insights. Aged exoplanets like this one provide an excellent opportunity to test our models of planetary development and gather valuable information about the later stages of extrasolar worlds. Epsilon Indi b appears to be literally swallowing up some of its infrared radiation. Scientists speculate that clouds in the gas giant's atmosphere might be responsible for this absorption, but other chemical compounds like methane, carbon dioxide, and carbon monoxide could also play a role. Fortunately, experts are already planning to dive deeper into this mystery, and if all goes well, we should soon uncover the true reasons behind the suppressed radiation flux. First, let's talk about the James Webb Space Telescope itself. This massive piece of technology is NASA's most advanced space observatory, equipped with infrared vision that allows it to peer into the deepest corners of the universe. Unlike the Hubble, which is limited to visible light, Webb can see what our eyes cannot. Its powerful mirrors and sensors are designed to capture the earliest light in the universe, giving us a glimpse of how galaxies formed billions of years ago. But what makes this latest batch of images so terrifying? Let's dig into that next. The James Webb Telescope recently sent back images of galaxies that are unlike anything scientists have ever seen. These distant cosmic structures appear warped and twisted, almost as if they're defying the laws of physics. Some astronomers speculate that these bizarre shapes could be caused by gravitational lensing, where massive objects like black holes warp the light of objects behind them. But the truth is, we don't fully understand what's going on here. Could these galaxies be harboring secrets that challenge our current understanding of the universe? One of the most chilling discoveries Webb has made is the detection of supermassive black holes at the centers of these newly discovered galaxies. These black holes are far larger than anything we've previously identified and their gravitational pull is strong enough to distort entire galaxies around them. What's even more unsettling is how quickly these black holes seem to have formed, defying our understanding of how they grow over time. Could this mean that black holes are even more mysterious and potentially more dangerous than we ever thought? Another puzzling aspect of these images is the strange distribution of dark matter. Dark matter makes up most of the universe's mass, yet we can't see it directly. What we can see is how it affects the movement of galaxies and other celestial objects. The new data from Webb suggests that dark matter may be behaving in ways we didn't expect, possibly pointing to new physics or forces at play. Could this be the key to unlocking one of the greatest mysteries in modern science? Or are we looking at something entirely new? So, what do these new images mean for the future of space exploration? The James Webb Telescope is showing us that the universe is far stranger than we ever imagined. These discoveries will push the boundaries of astrophysics and could reshape how we think about everything from black holes to the origins of galaxies. The implications are enormous, ranging from how we understand the Big Bang to what's really out there beyond the observable universe. One thing's for sure, we've only just begun to scratch the surface of what the Webb telescope will uncover in the coming years. One of the standout features of the James Webb Space Telescope is its ability to observe the universe in infrared wavelengths. This is particularly important for studying celestial objects that are too cold or too distant to emit visible light. Webb's infrared sensors allow it to see through cosmic dust clouds, revealing hidden stars, planets, and other phenomena that would otherwise remain invisible. This technology is revolutionizing our understanding of the early universe and the formation of celestial bodies. The images from Webb have revealed star-forming regions in unprecedented detail. By studying these areas, scientists can learn about the processes that lead to star and planet formation. Observing the gas and dust in these regions allows researchers to understand how stellar nurseries operate, the conditions necessary for life, and the potential for habitable worlds. Each new image brings us closer to answering fundamental questions about our cosmic origins. Another exciting aspect of Webb's discoveries is its ability to study planets located outside our solar system. By analyzing the atmospheres of these distant worlds, Webb can detect the presence of water vapor, carbon dioxide, and other essential elements for life. The possibility of finding habitable conditions on these exoplanets has sparked a surge of interest in astrobiology and the search for extraterrestrial life. The James Webb Telescope's findings are not just about individual celestial bodies, they're also revealing insights into cosmic evolution. By observing different galaxies at various stages of their life cycles, scientists can piece together the history of the universe. This timeline will help researchers understand how galaxies merge, grow, and evolve over billions of years, giving us a clearer picture of the universe's past. With every new image, the Webb telescope also uncovers cosmic mysteries that challenge our understanding of physics. For instance, some galaxies appear to be forming stars at an astonishing rate, much faster than current models predict. These anomalies force scientists to reconsider their theories about galaxy formation and evolution, leading to new hypotheses and exciting avenues of research. Webb's observations have significant implications for our understanding of the expansion of the universe. By measuring the light from distant galaxies, scientists can gather data on how fast the universe is expanding and whether this rate is changing. This information is crucial for testing theories about dark energy and the ultimate fate of the cosmos. Dark energy is one of the most mysterious components of the universe, believed to be driving its accelerated expansion. The James Webb Telescope's capabilities allow scientists to study the distribution of galaxies and the cosmic web, which may offer clues about the nature of dark energy. Understanding this enigmatic force is vital for comprehending the universe's structure and destiny. The images captured by Webb are also helping astronomers map the large-scale structure of the universe. By analyzing how galaxies cluster and form filaments, researchers can better understand the underlying forces that shape cosmic architecture. This mapping process reveals patterns that could unlock further mysteries about the universe's formation. The James Webb Telescope has provided fresh insights into the life cycles of stars, from their birth in nebulae to their explosive deaths in supernova. These observations enable scientists to study the chemical processes that occur during each phase, shedding light on how elements are produced and distributed throughout the universe, ultimately contributing to the formation of new stars and planets. The prospect of finding life beyond Earth is one of the most tantalizing questions in science. Webb's ability to analyze exoplanet atmospheres could provide vital information about potential biosignatures, indicators of life. By studying the chemical makeup of these distant worlds, scientists can assess their habitability and determine if conditions exist for life as we know it. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.